Hello everyone, welcome back to the channel. In this video lecture, we shall solve this problem, substring with concatenation. This problem is a Leetcode Hard problem. In this problem, we're given a string as an array of string words. All the strings of the word array are of same length. Then, a concatenated substring in S is a substring that contains all the strings of any permutation of words concatenated. That means, for instance, we have a words array and all the substrings generated by any permutation of these words would be a valid substring. Fine. So all these substrings, that is A, B, C, D, E, F, A, B, E, F, C, D, they all are permutations of the given set of words. Hence, all of them are concatenated strings. So all we have to do in this problem is to return the starting indices of all the concatenated substrings which are present in the parent string S, and the answer can be returned in any order. So we can return the indices starting from the last index ending at the first index, or vice versa. Let's see the constraints of the problem. The string which we have can go up to 10 to the power of 4 in length, while the length of the words, or the number of words that will be given, would be 5000, and the length of each word may go up to 30. Fine. So let's understand the problem statement using an example. Okay, so this is the example test case. Let's understand how the answer for this input test data will look like. We know from the problem statement that the length of strings given in the words is same. Let's say it is k, and the length of the words is m. Then the substring that we would have, that we want to search in the given parent string, is of length k into m, because the substring must be a concatenation of all the words. So in this case we can have only two permutations because we have only two words. The first permutation is this and the second permutation is this. So these are the permutations that we can have in this words array. So if we find any of these two substrings in this parent string, then the starting index of that substring would be one of the elements or index in our answer array. So let's start from the first character of the parent string. It is BARFOO. So we can see that this is indeed a substring which is formed from the concatenation of the words, that is here, that is this. Hence this index, that is 0, is one of the integer in our answer array. We can see that there is no word in this array which starts from A, so we move further. R is also not present in any of the words that we have as the first letter. Then we move to F. So we can see that this word is present in this words array, but the next word of length 3, that is the, is not present in the words array. Therefore we have to skip this word because it is not the concatenation the words which are present in this array. So we keep moving further and we find another such valid substring here, and the starting index of this substring is 9. So this is the answer, and we can return this answer in any order. So 0, 9 as well as 9, 0, both are valid answers. Okay, so let's see how we can solve this problem. First of all, there are few observations that we can make. The first observation is that the concatenated or valid substring in the given S, that is the parent string, which contain all the strings of any permutation of words. So the first observation says that a valid substring must contain all the words that we have in our words array. Okay, this is the first observation. The second observation is that all elements in the words have same length. Let's say this length is k, and we know that we must include all the words of the words array in some order or permutation to form a valid substring. So let's say m is the length of the words array. So the substring that we want to search in the parent string S would be of length k into m. Like in this case, we can see that the length of individual word is 3 while the length of the array is 2. Hence, we want to search for a substring of size 6. So, to solve this problem, the target is simple. We want to find the starting indices of the substrings of this length k cross m, that is 6 in this case, which must present all these words in some order. So the most naive way to think this type of problem is to just think of all the substrings of size 6. So let's take the first substring of size 6. The first substring of size 6, and we check if this is a valid substring. How we can check that? For that, we can use a hash map in which we can make the entries of these words, and for this string that we are checking, we can traverse over this substring and check if the particular word is present in the hash map or not. So we start iterating over this substring that we have chosen, and we see bar is present in the given hash map. So we move to the next word, that is this, and we see FOO is also present in the hash map because we have made that entry right from here. Hence, this is a valid substring. Fine. So that's the strategy. Then to find the next valid substring, we start from the next character, that is A, and so on. So that's the intuition to solve this problem. Okay, so the approach is simple. We just check all the substrings of size equal to word size, that is the number of words in the given array multiplied by the size of each word. That will give me the size of the valid substring that we want to search. Okay, so this is a hash map and this is the words array. So we can start. So let's see how we can solve this problem. So we start from the first character, and we know we want to search for a substring of size 3 into 2, that is 6, where 3 is the size of the word and 2 is the size of this array. Then we choose first substring of size 6 and we start traversing this substring, and at each index we check if the word that we have, so here we have B, here we would have BA, while here we would have BAR. So we would check if the given word is present in the hash map or not. So we choose first substring of size 6, then we make jumps of word length. So starting from this index, we make jumps equal to the size of the word that we have. So the size here is 3, so we have to choose 3 characters. So we choose 3 characters. We choose BAR and check if this BAR is present in the hash map or not. It is present in the hash map, so we decrement the entry by 1 here. It becomes 0. Then we move to the next word of size 3, that is FOO, and we can see that this is also present in the given hash map, hence we decrement the entry by 1 here. Here we can see that while we have traversed the given substring of size 6, we have exhausted all the entries in the given hash map. That means we have used all the words which we had in the words array for constructing this substring. Therefore, this substring must be made from some permutation of the given words. Therefore, it is a valid substring. Hence, we push 0, which is the starting index of this substring, into our answer array. Then we start same process for the next index, that is from this character A, and we take another string of size 6. So we choose this substring now, and so on. While we choose a substring, we must restore our hash map to the initial values. That means we must set the entries to 1 here and 1 here. This can be performed by using 2 hash maps. So one hash map is a global hash map which stores the entries of this words array, while a local hash map is used for each substring. So for each substring, all we do is we copy the values from the global hash map into this local hash map, and then we start traversing the string that we have chosen. Fine. So in this case, we would find 2 indices which are valid, that is 0 and 9, where our valid substrings are found. This is a strategy to solve this problem. Let's see the implementation for this approach. You can see that we use a hash map. This is a global hash map which is used to store the entries of the words that we have in the words array. This is the word length, which represents the length of each word in the given words array, while this is the substring size variable. It stores the substring size which we want to search in the given parent string, and k represents the size of the words array. Then this check function basically checks if the substring starting from index I, which is of length this substring size, is a valid substring or not. So this is a boolean function or a predicate function which gives me if the substring starting at index I having a size of substring size determined by multiplying the length of words array with the size of each word is a valid substring or not. So here we take a temporary hash map, we copy the values of this hash map, that is global hash map, into this temporary hash map. Then we declare a variable words used which will count the number of words which we used to generate the particular substring. Then we start iterating starting from the index I that we have here, and we make jumps of size word length. That is, we take each word, we take number of characters equal to the word length of the words present in the given words array, and we check for each word, that is starting from j, of this length if it is present in this hash map or not. That means if this word was present in the words array or not. If it was present, then we decrement the entry from the hash map and we increment our words used variable by 1. That means we have used this word to construct our substring starting from this index, that is j. Otherwise we break. Finally, that after we have traversed over the substring, we check if the number of words that we have used to construct that substring are equal to the length of the words array. If it is the case, then this function will return true, otherwise this function will return false, indicating that the target substring is present or not. Then this is the main function or find substring function, which takes in the parent string and the words array. It stores the starting indices of all valid substrings. So n represents the length of the string, k represents the length of the words array, words length represents the length of each word, and this substring size represents the size of the substring which we want to search in this parent string s. Then we build our hash map here by iterating over the words. Then we initialize an answer array and we iterate starting from the first index n minus substring size times. So n we know is the length of the string. So let's say if the string has a length of n, then obviously we would iterate for n minus the substring size that we want to search, because the last substring would be found at index n minus substring size if there is a valid substring which is present, if the given string is ending with a valid substring. Then for each index we are calling the function which we understood in the previous slide. It checks if the particular substring is starting from the index I or not. If it is starting, then we push that index in our answer array, and finally we have our answer array prepared and we return the answer array right from here. So this is how the find substring function is working. First we'll discuss the time complexity of our check function, which I explained here. Then we will move to the time complexity of the find substring function, which is using that function. Fine. We can see that in check function we are first copying our hash table. We have to copy the hash table, the global hash table, into this temporary hash table here. It takes in linear time of m time, where m represents the length of the words array. Then we are iterating m times starting from index I that we passed in the check function. So here we passed I and we are iterating from this I up until I plus substring size. That means we are iterating substring size times. So whatever the size of the substring is, we are iterating, okay, and we are making jumps of size word length. Fine. So we are checking word length at a time. Then for each such iteration, I iterate over the word length. So here I'm iterating over the word length to construct a substring which is of size equal to the word length. So that is giving me a time complexity of m cross word length. Fine, because we are iterating m times, and for each m we are iterating word length. Although time complexity big of m, which is handling this case, plus big of, that is we are iterating m times from this, and that is giving me m multiplied by word length, but the overall time complexity would be this m into word length. Then we see that this check function, which has the time complexity of m multiplied by the word length, is called n minus substring size times. So we can see that here we are calling this function each time we are iterating, and we are iterating n minus substring size times. Therefore this function is called n minus substring size times. Therefore the overall time complexity becomes m multiplied by the word length multiplied by the n minus substring size. Fine. Then the space complexity for the given solution would be big of m plus word length. Why? Because we can see that we are using a hash map which stores entries which are equal to the number of words in the given words array. That gives me big of m space complexity, while I'm storing. So here we can see that in this substring, in this variable sub variable, we are storing substrings of size equal to the word length. This adds an extra space complexity of big of word length. Hence the overall space complexity becomes big of m plus word length. Fine. So the time and space complexity for the given solution. Let's move on to the implementation part. Here we declare a global hash map for storing our words given in the words. Then we declare our word length, substring size and k respectively. Then we create our check function which takes in the starting index of the substring that we want to search and the parent string that we have. In this function we are first copying the given hash map into the temporary hash map dict. Then we are using a variable words used which will count the number of words which we are using to construct the given substring. Fine. Then we are iterating over the target substring starting from the index I with jumps of word length, and we are checking if the substrings which are of length word length here are present in the given dictionary or not. If they are present, then we increment the words used by 1, otherwise we break out of the loop. Finally, we check if the words used to construct the target substring which we want to construct are equal to the number of words in the given words array. If it is the case, then we would return true from here, otherwise we would return false from here. Let's implement our find substring function which takes in the parent string and the words array. So we calculate the length of the string, length of the words array, the length of each word in the array, and finally the substring size which we want to find. Then we build our global hash map from the given words array. Then we are declaring our answer array. Finally we are iterating over all the indices of the given string, and for each index we are checking if the substring of the size, substring size, is a valid substring or not. That means whether it is constructed from the given k words or not. If it is the case, then we push that index in the answer array, otherwise we move on to the next index. So this is how the function is working. It basically, so this function returns this answer array. So we return our answer here, answer array right from here. So this is the implementation in C++. Let's see the implementation in other languages. So this is the implementation in Java, and this is the implementation in Python language. So that's all for this video. If you like the video, then do like it and make sure to spread the word and subscribe to my YouTube channel. I will see you in the next video.